So, yesterday we discussed just the very preliminary concepts of our performance estimation. So, we have the first method called the holdout method. The holdout method is our conventional method which we are following so far for example. That is, we are just considering 50-50 training and test data, or we are using 2/3 data for training and 1/3 data for testing. This is the holdout. And random subsampling is another method wherein you choose randomly the samples. And the other one is cross validation. That is, we partition the data into k disjoint subsets, and we use the k-fold cross validation, wherein we use k-1 partitions as training data and 1 partition as the test data. So this we repeat k times. That means each time one subset will be the training data set. Once the cycle is complete, entire data will be there in the testing cycle. Okay. Now let us see holdout. The single holdout, repeated holdout, cross validation, k-fold, and level 1 out validation. And you have the bootstrapping concept also. Okay. Now in holdout estimation, then what is the key idea? Reserve a certain amount of data for testing and use the remaining for training. That is the key idea in holdout estimation. Now in such case, what are the problems you face? For small or unbalanced data sets, instances might not be representatives. That is, the data used for training and testing may vary significantly. These are the problems we face with holdout estimation. That is, I would like to explain this. Okay. So the key idea is we are reserving disjoint sets, some amount of data for training and the remaining data for testing. That is what we are doing initially. Now with this, what are all the problems we face? Suppose if the data set is small or it is unbalanced data set. What is meant by unbalanced? What is meant by unbalanced? Can anyone say? You can type it. Can you say what is unbalanced? What is meant by an unbalanced? Nobody wants to answer? See, I told you whether it is right or wrong, please try to respond so that you will have a thought process initiated. Hello. You can raise your hand. data set contain biased set of classes. Right, you are one way correct. You are one way correct. The exact thing is, yes, it's not biased purposefully, but it may not have all representatives, or the representatives may be there with some disproportions. Okay? Unbalanced means you may have all representative samples, but in not appropriate proportions, or some of the samples can be missing in the smaller data sets. So the instances may not be represented. So the data, another thing is, the data used for training and testing may vary significantly. Because you are bifurcating the data. Okay. So in bifurcation, it may so happen that the samples representing one kind of aspect may not figure out in training data set, and they may totally come to the testing data set. Then what happens? You will be developing the training model without those samples, but these samples figured out in testing. Then obviously you will not have a correct, will not have a proper error rate for training set. The error rate for the training set will be higher. So that is the problem you face with this kind of hold-out estimation. But this is very simple to use. But these are the limitations of this. Now, stratified hold-out. Stratified hold-out, how it happens? The general hold-out using this sampling base generates new subsets of instances with an approximately equal proportions of classes. In fact, this is a good idea. Here, this is to solve some difficulty you face with your standard holdout. So what do you do in your standard holdout is, Parvati garu ettina class na mani cheppanడి. Hello. So the one difficulty with this holdout is you will not have the representative samples problem. So here you generate the stratified holdout. You generate using some stratified sampling technique. That means you generate new subsets of instances with an approximately equal proportion of classes. That is one thing. And you ensure that classes are equally represented in the samples. Students, I can see you now. You are visible to me. You are visible to me now. Are you following? Huh? So, am I clear now? to you? Okay. So this ensures that the classes are equally represented in the samples. This ensures that classes are equally represented in the samples. That is the advantage with the stratified holdout. Okay. What is repeated holdout? The repeated holdout or random subsampling improves the reliability of holdout estimate by repeating the process with different subsamples. That means in each iteration, certain proportion of data is randomly selected from data. The error rate on different iterations are averaging to yield an overall error rate. In this case, what is the problem you will have? You may have an overlapping test sets. That is the problem. You may have overlapping test sets. That is, in repeated holdout, what happens is we reserve some proportion of the records generated from random subsampling. So in each iteration we do this job. So certain proportion of data is randomly selected for training every time. So the error rates will be different, but they will be averaged out because your space is more and you are doing random sampling of more number of things. Okay. Next is the cross validation. So some of the negative points of your any problem? Cecilia? So the problems of your holdout are being taken care by the remaining steps of the methods. Okay, are you clear with holdout? Hello? Are you clear with your holdout method? Raise your hands, those who are clear with it. If you are clear, I will go ahead with cross validation. Are you clear? Hello? JNTUK Canada, please you can raise your hands if you are clear. Is it clear to you? JNTUK Vijayanagaram. Vijayanagaram, is it clear to you? Aditya, Lendi, is it clear to you, my dear friends? Are you clear with the holdout method? Please respond yes or no. You can. Now the thing is cross validation. Cross validation ensures no overlapping of test sets. Because what is that we did? Each time we have decomposed the data, we have divided the data into K subsets and we are making one set as test set and the remaining K-1 sets as the training data sets. So each time it ensures non-overlapping of test data. That is one. So the error estimates are averaged across each of the K-folds. That is how the cross-validation test happens. Now let us see the issues or concerns. See, divide the data into K-folds. See, 10-fold it is made. Now out of the 10, fold 1 is used for testing, the random is for testing. Remaining 9 are for training. In the second round, the test fold 2 is for testing and remaining things are for testing. Then like that in the last round, fold 10 is for testing and remaining are for testing. Now what are the specific characteristics or properties of classification? The same instance once selected cannot be selected again for a particular training testing set. That means one sample will be there only once. It will not be repeated. There is no replacement. It is computationally expensive. And variance also will be high. Computationally expensive in the sense each time the data is changing, each time you have to generate the tree, you have to do the process. So it's expensive one way, and variance tends to be high. Why the variance will be high? Can anybody say? Why variance will be high? Can anybody answer? You can just type it in the chat. Why variance will be high? Why variance will be high? Anybody say why the variance will be high? Because each time you choose, so you are reluctant to answer. I told you many times, whether it is right or wrong, you respond something. Never ever ignore. That means you are not interested. That's simply says. At least you are not answering. So you are actually talking his own way. So the variance tends to be high reason being each time you get a disjoint set of test data. So obviously the error rate, testing error rate varies because each time it is on a disjoint data set. So obviously the variance in the test data will be high. Okay. I am very unhappy for your non-responsive nature. I expected at least someone will come. Now, Bootstrap uses sampling with the replacement to form the training set. So, how do you use the sampling here? You have a sample data set of 10 instances. N times with the replacement to form a new data set of 10 instances. Then use this as a training set. And use the instances from the original data set that do not occur in the new training set for testing. So how does this go? See, you should have some clarity here, the Bootstrap. You take a sample data set of 10 instances, keep it. So, n times you choose the elements, because previously holdout or cross validation, what is that you are doing? No sample is repeated there. Because in cross validation, you divided the data into K sets and you have taken k minus 1 sets, and for testing you took the last bit. Okay, so you have k minus 1 testing data, k minus 1 parts of testing data, one part of k minus 1 parts of training data, and one testing data set. So there no record is replaced. But here in Bootstrap, the difference is that you will replace the element again. That means you have n elements there. So from the n elements you randomly choose one, put into the training set. How it works is, you have taken n data set. That set is there at one point. And you have a training data and test data, two boxes, let us say. So how you will choose training data? I'll come to that first. So you have the box of n data records at your disposal. So from this box you take one sample randomly, put it in training data set. You replace it back in your original data set also. Previously what you have done, once a training sample is chosen, it is removed from the data set. But here you are not removing it, you are replacing it. So that means for the second iteration also, you have n records. Now again, you sample one record from that, put it in the training set, and replace it back in the original box. So that means at any point of time, all the n records are there in the original data box. None of them is removed. So in each iteration, you are randomly picking up one sample. So in this case, what happens? You have a possibility of the records being repeated. Do you agree? You have a possibility of the records being repeated. Now what happens is, after taking n samples like that, so that means you may say all the n records should figure out, need not necessarily. Because here some records repeat in training data set. So now you consider you have n records as usual in original data set. You have some n records in the training data set also. But in the training data set, n records, please remember that they are not distinct. So if you consider the distinct records from the training data set, they will be less than n. Do you agree with me? Hello? No response. You don't want to respond, or you don't bother about it? Anyway. But I am very, very unhappy and dissatisfied with your non-responsive nature. I am sorry to say this. Okay. So in this case, you have a original data set of n distinct records. So you just said SR, that means we are not bothered. Is the meaning of your SR? I wanted a response whether you have understood or not. In this case of bootstrap, you have the n distinct records on the original data set, and you have n records in the training data set. But in the training data set, n records, they are duplicates, they are repetitions. So those repetitions, if you consider, the distinct set will be less than n. Now what happens is, from the original data set, you remove the distinct data elements that are chosen for training. So the balance records you use for testing. Have you followed? That is, accepting the records that are there in training data set, remaining data set you consider for testing. Okay. Now, using this, what is the advantage? What is the probability of one item not being selected? Because each time you are randomly choosing the stuff. So what is the probability for one element not to be chosen? You can type in here. Suppose I have n elements. So what is the probability of not choosing one element? Or else if you have n elements, what is the probability of choosing one element? Can you tell me? You have n elements in a sample space. What is the probability of choosing one out of those n elements? What is the probability? You just type in. What is the probability? Type in the probability of one element chosen. Very good. It is n minus 1 by n. 1 by n for choosing, right? Very good. So 1 by n for choosing an element, and for not choosing the element, it will be 1 is the total probability. So 1 minus 1 by n is the probability for not choosing. So in a random sampling that happens for n times, what is the probability of an element being not chosen? It is 1 minus 1 by n into 1 minus 1 by n into 1 minus 1 by n. N times, right? So it is 1 minus, I am showing the next slide, the derivation. See, an instance has a probability of 1 minus 1 by n of not being picked up for training. So the probability of ending up in the test data is 1 minus 1 by n to the power n. Because the not chosen elements only will be there. And when n is large, your 1 minus 1 by n power n will be equal to e power minus 1. Your e is 1.27 and God. So e power minus 1 will be 0.368. So that means what they say is the training data set will contain approximately 62% of the instances. Because the probability is 36.8% for non-choosing of it. So here we consider that using your bootstrapping, 63.2% of the instances will be considered for training. The remaining 0.368 will be considered for testing of this. So this is your bootstrap. So with this, how do you estimate the error? You estimate the error as a weighted average, because the training was done on 63% of instances. So the error will be considered as weighted average of 63% of test instances error rate and 36.8% of training instances error rate, because you have training error as well as testing error. But the error is considered as final error of the model is considered as the weighted average of test and training instances error rates. So the resubmission of error gets less weight than the error on the test data. This is what you have to remember. Error on the test data will be more here, and instance or training data will be considered to be less here in this case. Okay. So the properties of the bootstrap, what are the things? For small sample size n, bootstrap will have much smaller variability than cross-validation estimate. Because in your cross-validation estimate, you find out lot of variance, we say. Because I told you, reason being each time it is a distinct scenario and all. But here with the bootstrap, your records in the training data will be repeated and all. With this, the variance is small. That is one observation. And bootstrap and CV estimates will generally be close for large sample size. For large samples of data, your bootstrapping and cross-validation estimates will be giving close results. That is another observation. The ratio will approach unity as the sample size approaches infinity. This is obvious, because more the number of records, more general it will be. And obviously, as the sample size tends to infinity, obviously the ratio also will approach unity. So this is about your classification methods. Is it okay for you? Is it alright for you? Doubts on classification? Yes means yes, then you please raise your doubts. No. So you are just habituated to say yes sir for whatever I say, right? That's why without understanding what I say, you are saying yes sir, yes sir. So with this I conclude the classification unit, and we are entering into the fifth unit, that is the association rule. Okay? Hello? Shall I proceed with the new unit, or you have anything to ask in classification? Say yes sir, yes sir. Hello. So shall I proceed? Now I am going to the new topic, That is the association model. So we'll start with this. What is this association? What for we use this? Try to understand first of all why you have to study the association model. What are the advantages? Normally, the many business enterprises, they accumulate large quantities of data from their day-to-day operations. Do you agree with me? The organizations, the business organizations will accumulate lot of data from various transactions that happen in their business. Then, what is the advantage of gathering that kind of large data? Is it of any use for you? Can you use these transactions for any analysis purpose? Because if you come back, we discussed that down the line, the idea of going for a data warehouse, then for mining, everything, these are all part of the knowledge discovery process. What is your knowledge discovery process? Ultimately, you want to find out certain useful results or useful patterns out of the existing knowledge. So for that you are collecting the task relevant data, and on task relevant data you are applying some techniques to make it ready for interpretation. So you build data cube to answer certain things. You have used classification techniques, decision tree and all to extract certain knowledge patterns of classifying things, right? So based on the different data that is available and based on the requirements of the data, you will go ahead with a specific technique. Now, what are the things you achieve through the association rule mining? That is, in the business organization, you have accumulated lot of data by end of the day. Now, that means you have very huge amount of customer purchase data collected daily at the counters. Now, using this data, what is that you can do? Can you do any kind of processing with this data? That is, normally what happens, you see, you get some flyers from different shops. Suppose more supermarket is there, or Spencer's market is there. You get flyers saying that this week there is a very good reduction. If you buy some 2 kgs of Spencer atta, we give 5 kgs of potatoes free of cost. Okay. So if you buy atta, you can make potato curry free of cost. The potatoes will be available for you. Or we give you 1 kg potato, 1 kg onion free with 20 kgs of wheat flour. Or they say, so and so wheat flour of 10 kgs purchased with a 5-liter oil tin. We will give this much reduction on the oil tin Additionally, we will give you 1 kg of potato or onion free. Or you buy some 3 items, let's say, then 4th item will be totally free. Or 4th item you will get for 50%. Like this, you get some deals announced in the shops, announced by the shops. Then what you will do, the people will see, oh, this deal is a good deal. Let us go and buy the shop. Let us suppose today Apple company announces that we are giving a discount of 20% on an iPhone 6 if you buy one iPhone 6. Suppose if it says you buy one iPhone 6, then we will give you some 20% discount on the second iPhone. Or they may say 30% discount on second. Then people will rush to the Apple stores and make it. Right? So normally, why these business organizations give this kind of discount? This is basically to enhance their sales. They want to optimize their profits. So, if they want to optimize the profits, why should they offer one item free or one item, if one item is purchased, giving 20% discount on the second item? Why should they do that? If they want to optimize their profits, they should not reduce the price. Right? That is the fundamental thing you do. But here, they plan a perfect strategy. What they do is, for this strategy, they say that, yes, with this discount, let us suppose I am losing some 20 rupees on each transaction. Suppose normally 100 transactions are happening. With the reduction you have announced, I am losing 10 rupees per transaction. Let us suppose. But even though you lose 10 rupees a transaction, it's not basically loss. Please remember. You are getting reduction in your profit. That means the production cost of your item is 50 rupees, let us suppose. Then your sales price is 100 rupees. Your sales price is 100 rupees. Your production cost is 50 rupees. So you have 50 rupees margin. But suppose yours is a very popular product, hence it is a branded one. The people are buying your products very quickly. So by selling 100 items, you are getting 50 into 100, that is 50 into 100, that is 5,000 rupees of profit. But let us suppose by reducing the amount from 100 rupees to 90 rupees for these items. You say that if you buy second item, then 20% reduction means for every item it has become 10% reduction of this. So in such case, you are selling it for 90 rupees. You are losing 10 rupees of the margin, but still that means only 40 rupees margin is there. But still instead of 100 sales, if the sales increases to 200, what is happening for you? If the sales is doubled, though you lose 10 rupees margin in your item, but by virtue of the increased rotation, your profit is much higher. That is, you have sold each item for 90 rupees instead of 100. So when you have sold 100 items, you had a 5,000 profit. But because of this reduction, you have sold 200 items. So 100 items business has increased. So though you reduce 10 rupees there, you have gained an additional return of 40 rupees for each item only instead of 50. But still, the overall profit, if you consider, it is much higher because the previous thing is only 5,000 rupees because the difference is 100 minus 50. But now it is 40 rupees margin on each component. But you have sold 200 components. So it is 200 into 40. How much it comes to? 200 into 40 is 8,000. So previously your profit is 5,000, but now your profit is 8,000. So even though the audio is not clear, Sasigaru, Chakravarti garu, they are complaining that the audio is not clear in JNTUK Kakinada. Please check this. So here I will just stop for 2-3 minutes so that the audio will be separate and up. So we will meet in 2 minutes. So now, as these people said, with your reduction in the profit by 10 rupees, still the original cost is 50 and you are selling it for 90 instead of 100, but the turnover is more, so the profit increased from 5,000 to 8,000 rupees because the rotation of the sales has done. So now why they say buy 2 get 1 free, buy 3 get 1 free, buy 1 and get the second one 20% reduction, or buy 1 and get the second one for 50%. Why the variation in this kind of things? What they do is they always analyze what is the frequency with which some element is going. They estimate using their own methods. Suppose if the price goes down by this much, how much increase will be there in the sales they will increase. Then they check that kind of stuff and they decide, yes, this much reduction will increase the sales by this much percentage. So hence this kind of reduction is optimal. Like they choose the optimal strategy for the reduction at the other item. So based on that, the issues will happen. So based on that, they decide, yes, you can give, if the second one is purchase means you can give 20%, otherwise 10% only, you can give 50%. Let us suppose what happens is the movement of one item is very dull. So that is occupying your maximum inventory space. Somehow if you vacate that space, that can be provided for a very hot item. So in such case, people say, okay, buy one, get the other one for 50% price. Then the sales will increase. The profit will be better compared to the normal, even though he reduces 50%. Sometimes he might lose some amount, but the thing is, the loss will be reduced. By your means, the loss will be reduced. So, for this, for deciding this kind of business strategy, the important aspect in it is, which are the frequent items that go in sales in our shop? That is one concept. And the second concept is that how much reduction you can give on these things. And third is which items go together well. That is the very important aspect here. Because if you know that, suppose bread and milk are purchased together by majority of the people, then what you can do is in your sales, near the bread you can keep the milk also. So that a person comes for buying bread, will see, yes, I need to buy milk also. You will see. Or if any special deals for the component like milk are there, or bread are there, you can keep these two things together. Then you will announce, yes, we have a good reduction on the bread. You buy one bread, the second bread packet is free. Buy one get one free for a bread, good deal. Then people will come, okay, the standard Spencer's bread is good, so let us go and buy the Spencer's bread. It's giving buy one get one free. People will go there. Then you will keep the milk bottles also there. This is a new milk from some company. The original price of other branded milk is some 100 rupees the packet. This packet we are offering for 75. Just please check. Like you can canvas, and people may say, okay, we have this deal and bread point. We can test this milk for a 30% reduction. There is a new company milk that has come. Let us see, like people may feel and buy. Or people who forgot about milk originally in their list. Once the bread and milk are there together, they may recollect, yes, we forgot milk. Or else we have only small quantity of milk left in our house, so let us buy another 5 liters of milk. And they may feel like that. So for that sake, knowing the psychology of customers, they keep the items that go more frequently together at one spot, and they give reduction on the items that go together at one stage. That means if you offer a bread and milk purchase it together very frequently, then if you give a discount offer on bread as well as milk, people will feel fine, we will go and buy the bread and milk also to cater our needs. Like people will think and purchase both the things together. So to find out that kind of togetherness and to optimize the business profits, you should have a methodology to find out which items go together well. So the methodology, the data mining technique that uses to find out which items go together well is called association rule mining. So the concept of association rule mining has evolved from the business requirement of finding out which items go together well. Based on that only, you can comfortably plan certain business strategies. So association rule mining is one new category of your data. So in the data mining so far, you have seen data warehouse ETL process. You have seen how the cube will be built. Based on the cube, you will be getting the analytics, you will be getting some plots and you are getting the output of or you are unveiling some patterns, and using classification you are predicting certain models and values. That is how it is useful. And in association rule mining, you will be finding out the items that are sold together in a marketplace. So hence this is called the market basket analysis. This is called the market basket analysis. So this is the philosophy or logic behind your market basket analysis, wherein the technique of association rule mining is being used for effective finding. Now let us see a market basket transaction example here, and see how different things will be. defined data. So we have a given set of transactions here in this table. Now we have to find the rules that will predict the occurrence of an item based on the occurrence of other items in the transaction. Okay. So what are the examples of association? We say diaper goes with beer. That means a person who purchases a diaper will be buying beer also. So if you look at first of all the transactions in this shop, these are point of sale transactions. The transaction ID 1 says the item bread and milk are purchased. Second transaction says bread, diaper, beer and eggs were purchased. The third transaction milk, diaper, beer and coke were purchased. In the fourth transaction bread, milk, diaper and beer are purchased. The fifth transaction bread, milk, diaper and coke were purchased. So from this, what are all the rules you can infer? I am not here mentioning the rules that are derived, but what are all the rules that can be generated, possible rules that can be generated and not. That is, here we say diaper determines beer. Your functional dependency, we call that this determines that. But here, if somebody purchases a diaper, he will purchase beer also. Another thing is milk and bread are purchased, eggs and coke are purchased. A person purchases beer and bread will purchase milk also. Here the implication means co-occurrence, not casualty. That means the casual things are not to be considered. You have to consider the co-occurrences only. So here I am defining certain terms. Okay, what is meant by an item set? Item set is collection of one or more items. Is an item set. What is meant by K item set? An item set that contains K items is a K item set. Suppose if you consider first transaction, bread and milk are there in this transaction. So this is a 2-item set. Bread, diaper, beer and eggs. There are 4 items in the second transaction. So second transaction is a 4-item set. Like this, how many items are there in a transaction? Then you say that it is that much number dash items. 5 are there, 5. 3 are there, 3 items. So what is meant by support? And support and confidence are 2 very, very important things. So support from sigma is considered as frequency of occurrence of an item. That is, you say sigma milk, bread and diaper. What is meant by that? So out of all the transactions, there are 2 transactions that contain milk, bread and diaper. You see, bread, milk and diaper together are there. First transaction, no. Bread and milk are there, but diaper is not there. Second, bread, diaper are there, but milk is not there in the second transaction. If you look at the third transaction, you have milk and diaper, beer and coke, but bread is not there. But here if you look at fourth transaction, you have bread, milk and diaper. And fifth transaction also you have bread, milk and diaper. So now here, if I say what is the support count of milk, bread and diaper together, it is 2. That means there are only 2 transactions that have the pattern, the milk, bread and diaper. That means these 3 items are purchased together 2 times out of the 5 transactions in this case. So that is the going after support. So the support count is different. Support is different. Support count is just the number of items. So there are only two number of items that have milk, bread and diaper. Now what is support? How does it differ from support? The support is fraction of transactions that contain an item. Previously support count is simply the number of transactions that, but whereas support is the number of transactions that have this pattern against the total transactions. That is, the total transactions are 5. So here the support says 2 out of 5 transactions have this pattern milk and bread and milk, bread and diaper together. That is the support. What is a frequent item? An item set whose support is greater than or equal to minimum support threshold is called a frequent. That is, here, if you consider what is meant by frequent item set is an item set whose support is greater than or equal to minimum threshold support is a frequent. Why frequent item is there? That is, in this business activity, you will have lot of transactions, no doubt that. You will have lot of transactions. But if you want to consider any transaction for its interpretation, it should have a minimum support. That means, what is meant by an association rule? Association rule means you are making a statement that if you these two items are sold together very much, or I want to say in the third year class the students are good, but how can you I say that the students are good in my third year class? Based on what? If I just consider 2 students and if these 2 students are good, can I simply say no? I have to watch at least half of the students minimum, and a majority are good in that half of the sample. Then I say that yes, the students of third year class are good. So that means I should have a sufficient enough sample to give my judgment about the thing. Just by merely seeing 1 or 2 things, if you say that yes, this class is good, that makes no sense. Okay. So here the minimum support count is defined. How do you define that minimum support count? The minimum support count is a threshold value, either support or support count. You can fix it up. It is a threshold value. It will be defined by the business user only, because observing his transactions, observing the impact of things on his transactions, he will decide himself which is the minimum level of support that need to be considered for considering that some statement is valid. So now what is an association rule? How the association rule is? This association rule is an implication expression of the form X determines Y, where X and Y are item sets. Or we say that X and Y go together. That is how you can define it. So we say milk and diaper gives beef, implies or arrow with beer means the people who purchase milk and diaper will purchase beer also. That is the statement. So the meaning of your association group, something like X recommends Y, is if X goes well, Y also will go well. That is the meaning of this association. Then rule evaluation methods. Here support yes means fraction of the transactions that contain both X and Y. Support is for this togetherness to define this support as a fraction of transactions that contain both X and Y. That is the support. And confidence is measures how often items in a given Y appear in transactions that contain X. So you should have, first of all, consider the transactions. That is the fraction of transactions that contain both X and Y. And then, for the sake of confidence, you consider this as a measure of how often Y appears in a transaction that contains X also. So here in this example, you watch, you have milk and diaper. The person who buys milk and diaper will obviously buy beer together with that. That is a beer. So here your S is the support count I said. It is sigma of milk, milk, diaper and beer. So it is, so the support count is for this milk, diaper and milk together is 2. So if you divide that with the total transactions, you get the support for this. Support count is different, support is different. So your support is the percentage of transactions that contain all the items together in a set capital X. Here your capital X is milk and diaper. Your capital X is milk, diaper and beer. So you want to see how many transactions are there that contains all the attributes across the entire space. That divided by the total sample space size will give you the confidence. Okay. Now, support. Confidence means this is once you have a transaction set, how many times both these X and Y are met together. You have a setup, you have a rule such that X implies Y. Here milk and diaper implies B. So what does it mean? You mean to say that a person who buys milk and diaper will buy bean also. So for that, what is the proof? You first of all take the transactions that contain milk, diaper and bean, all the three together, and divide that with the transactions that contains milk and diaper. So then you can say that that is 2 there, and 3 is the transactions that contain milk and diaper. You see, milk and diaper in the transaction 3 and milk and diaper in transaction 4 and transaction 5. There are 3 transactions that contains milk and diaper. There are only 2 transactions that contain milk, diaper and beer. So if you make a statement that the people who purchase milk and diaper together will purchase beer also. So what is the confidence with which you can say? Yes, out of the transactions, all the three items, two of them or 67% of them say that the person buying milk and diaper is buying beer also. So that is the confidence with which you can make the statement. So for any statement if you make, you have to decide with which confidence you made the statement, and you have to decide with which authority you have to do this. Confidence means togetherness of total items and these two items. Confidence means in total how many transactions are there with these three items together in the total data set. So that brings the confidence support for that. What I mean to say is, I told you, just by merely seeing two students who are bad in the class, you cannot say these students are bad. To make a statement of your own, you should have some support. That means you should have sufficient number of transactions that contain all the set of elements you have mentioned. So that is your support. And confidence is, okay, how much proof is there for your statement to say the truth? That is, you need all transactions that contain all the elements, and you take the transaction that contain the required element that is implying something else. You divide it by that. Then you say that this statement you made with so much of confidence. Is it clear, the confidence and support? Are you clear? Are you clear with the concepts of support and confidence? Are you clear with the statements of confidence and support? Okay. Then now I raise a question. Why do you need support for a statement? Because I have observed there are some 10 transactions in the database containing X and Y. Out of 10 transactions containing X and Y, both X and Y, 70 transactions with X. X is purchased, Y is also purchased. Out of 10, 7 transactions. So you have a confidence of 70%. Then when you have that much confidence, why do you need to consider support also? Please explain me. Can anybody say that? Judge the demand for this fine, but why do you need support means you made a statement, but to make the statement, how much support is there for you? That means your 10 transactions are out of 10,000 transactions of a database. So just by merely considering 10 out of 10,000 transactions of you can't make a state. Whereas if those 10 transactions are out of 30 transactions in a table, then you can say that I have 30% of support. That means the total 30% of the transactions in this database are with these elements only. So with that much authority, with that much support, I am able to talk. So out of those things, okay, 70% have satisfied this. Okay. So you have to have confidence, you should have sufficient support. So now, what is the association rule binding task? What is the association rule binding task? The association rule binding task is, given a set of transactions A, the goal of association rule binding is to find all rules having support count greater than or equal to minimum support. Not support count, I am sorry. Support greater than or equal to minimum support threshold and confidence greater than or equal to minimum confidence threshold. So, how do you do that? See, now we have defined very clearly that given a set of transactions E, the goal of association guideline is to find all rules that are having support greater than or equal to minimum support threshold. All the rules whose confidence is greater than minimum confidence. So that means, given a data set, you can infer so many rules, but all the rules are not valid. I was just repeatedly saying about the Thomas Alva example. That is, the birds can fly by eating insects. So they are flying just merely because they are eating the insects. But that doesn't have any support for you. There are sufficient support. So that means you will frame certain rules from the given data set. So if you have a given data set, you can have all combinational possibilities of the rules. How do we form this is what I am going to tell you. How we will form the rules, I am coming to that point. Because suppose you have two elements, let us suppose x and y. So you can say x determines y, or x implies y, or y implies x. Two rules you can do. Suppose you have three elements x, y, z. So you can say x implies y, x implies z, y implies z, xy implies z, yz implies x, and xz implies y. These are all the rules you can formulate through combinations. I will show you in the very next slides only. You will see how rules will be framed. So, and this basic brute force approach. That is, you list all possible association rules, compute the support count of and confidence of each and every rule, then prove the rules that fail to satisfy the minimum support and minimum confidence thresholds. This is computationally very predictable. Why I will tell. And let's show. Mining association rules. You see here, you have bread and milk, bread, diaper, beer and egg. Okay. If you look at, we are showing 1, 2, 3, 4, 5, 6 rules we have shown here. Milk, diaper implies beer. Milk and beer implies diaper. Diaper and beer implies milk. Beer implies milk diaper. Diaper implies milk beer. Milk implies diaper and beer. So, my dear friend, you check here. We considered only 3 items. Of course, you have Coke and egg. The other items are also there. For a while, I am telling you, we discarded eggs and Coke here. Why we discarded eggs and Coke, I will explain. So, by discarding eggs and Coke, we have only remaining 3 elements. So the 3 elements are beer, milk and diaper. So with these 3 things, we are making different permutations and combinations. They are your milk and diaper determines beer. Milk and beer determines diaper. So that is how we have generated all possible combinations of 2 item sets only. About 1 item set I need to speak. Only for your simplicity's sake I am showing this. I will explain you very clearly in the next class. Okay? Why we have considered like this and why we omitted eggs and Coke outside. This comes to your support component. Okay? So here, for this milk and diaper purchases beer. What is this support? What is the confidence? We have listed. Incidentally, support is 0.4 for all these things. And the confidence is 0.67 for first one, 1 for second one, 0.67 for third, fourth things. 0.5 for last 2 months. Suppose if you fix up the minimum threshold as for confidence as 0.67, then last 2 will go. So all the above rules are binary partitions of the same items. So now I will just stop here. Okay, and the next class, I will very clearly explain why you have single item sets, what is 2 item set from this. Why you have, because the Coke, suppose you have a minimum support threshold if you keep it as something. See, if you look at eggs are coming only once in the transaction. If you consider Coke, it is there once in the transaction. Here, the minimum support count is considered as 3. As the minimum support count is considered 3, egg and Coke, they are avoided because they fall less than the minimum support. So in none of the rules egg and Coke were not there. So we have done. Now the remaining things that are there in the list are milk, diaper and beer. So we will discuss in the next class with more clarity, because even if I say something that will be halfway through pruning the rules, the impact of confidence and support on these rules, and then how the brute force will be expensive compared to that. What are the arbitrary rules? Then how can you generate those things? Everything, every generation, all those aspects will be discussed in the next class. Thank you very much.